The naive Bayes classifier is a powerful tool in the field of data science, widely used for classification tasks. It operates on the principle of Bayes' theorem, which helps to determine the probability of a given outcome based on prior knowledge of conditions related to that outcome. This method is particularly favored for its simplicity and efficiency, making it a go-to model for tasks such as spam detection, sentiment analysis, and document classification. One of the distinguishing features of the naive Bayes classifier is its assumption of independence among predictors. This means that it assumes that the presence of one feature in a dataset does not affect the presence of another. While this assumption may not always hold true in real-world scenarios, the classifier often performs surprisingly well even when the data violates this condition. This characteristic allows for quick computations, enabling the model to scale easily with large datasets. Naive Bayes can be categorized into different types based on the nature of the data involved. The most common types are Gaussian naive Bayes, multinomial naive Bayes, and Bernoulli naive Bayes. Gaussian naive Bayes is suitable for continuous data that follows a normal distribution, while multinomial naive Bayes is ideal for discrete data features, making it highly effective for text classification tasks. Bernoulli naive Bayes, on the other hand, is specific to binary outcomes and is often utilized in cases where features are binary or Boolean in nature. Training a naive Bayes classifier involves a straightforward process of calculating the prior probabilities of each class label, as well as the conditional probabilities of each feature given the class label. Once these probabilities are established, the model can categorize new instances by applying Bayes' theorem to compute the likelihood of each class, ultimately selecting the class with the highest probability. This process not only provides a quick method to classify data but also offers insights into the relationships between class labels and features. In conclusion, the naive Bayes classifier remains a popular choice in data science due to its simplicity, efficiency, and effectiveness across various applications. Whether you are analyzing customer reviews, filtering out spam emails, or classifying news articles, understanding and implementing this model can significantly enhance your data analysis capabilities. As data continues to grow in complexity, the naive Bayes classifier provides a robust foundation for tackling classification challenges with ease.